what shall be its maximum stress? Guys, have any doubt in this? It's as simple as that. Okay, it's very simple. Now, I'm going to ask another question stating that this 5 kilonewton, as you are thinking, it is not acting in the middle. Okay, so let me ask you this. So instead of acting here, maybe I can take a fresh page. Give me a minute. Instead of acting in the middle, say the force is acting here. 5 kilonewton, 5 kilonewton. So it is acting at 10 mm away from the middle. Okay. Now give me a solution for this. Can anyone do that? Can anyone give the solution for this particular sum? Okay, or just say me this. Whether the load acting in the middle will be more than 12.5 or less than 12.5.
More
Guys,
than
yeah,
more than 12.5.
more than 12.5. Very good. Very good. Why?
Since the cross section is reduced from the both sides like that.
Have we reduced the cross section? I haven't touched upon the cross section. It's all the same.
The place with which it is acting,
Right.
it
Okay.
has shifted to the right, so it's more to the edge of one side. So
Okay.
I think moment will be active.
Exactly. So that is the answer that was looking for. So apart from the stress, okay, apart from the regular stress that's being acted upon, there will be additional momentum. Okay. So which can produce additional stress over this particular element. Okay. So what kind of loading is this?
axial.
This is what we call, note this is what we call eccentric loading. Okay, so this is what eccentric loading is. Okay, usually we consider every sum, every problem, we assume that the stress, the force will be acting along the centroidal area. Okay, always we consider the force is acting upon the centroidal area. Okay, but it may not be the case for every problem. Okay, every problem will be having its own problem, right? So it is acting eccentric to the centroidal of gravity. Okay, if our force is not passing through the centroid of gravity or centroid, then if it is offset or eccentric to the centroid, then we call it as eccentric loading. Is that clear? Eccentric loading na nan purida?
Yes, sir.
Okay, so let me just shoot out a few examples. Okay, let me ask you this. So let us. Is this eccentric loading sum? Is this eccentric loading sum? Is this eccentric loading? B.
No, sir.
What about this? Is this eccentric loading?
Yes, sir.
What about this? Is this eccentric loading?
No, sir.
Doubt avudalla?
Yes, sir.
Is eccentric loading or not?
No.
Any good? Why?
So it also passes through the center.
Exactly. So you should consider the line of action. That is the point. Okay. So if you extend the line of action, again it will be passing through the centroid. Okay. So if our force acting as passing through the line of action as in the centroid, okay, if our force having the line of action passing through the centroid, then it is not eccentric loading. It is as good as the previous sums. Okay. But when the line of action of the particular sum like this is eccentric to the centroid, then it is what we call eccentric loading. Okay. So do you understand the difference? Do you understand the difference? Is that clear?
Yes, sir.
Right.
Sir.
So how to solve this? Any idea? Anyone? Come on. You guys are fresh. You can answer this. Keep your minds open. Any suggestions to solve this sum? I will give you one clue. So we were discussing about this principle even in yesterday's class or day before yesterday's class. What is that?
Principle of superposition.
Exactly. So we have to make use of principle of superposition. Okay. So what does it states actually? So this is the principle of superposition. Okay. So for the record, you can make note of it. But still, without any understanding, if you have that knowledge without understanding, this is useless actually. Okay. But just try to remind this thing. If a force system acting on a body is superimposed with another force system that itself is in equilibrium, then the effect of both the force system remains same as that of initial force system. Okay, that is the principle of superposition. Okay, but do you understand anything with this? Do you understand? Can someone explain this? Can someone explain? Not really, right? So it's very difficult to explain. Okay, so saying the principle is easy, but explaining the principle is something that you have to develop. Okay, so even in your future, people will be interested upon your understanding of the principle rather than the principle itself. Okay, so you should focus upon that. Okay, so now I'll tell you example. Okay, let us have this object which will be having a center of gravity at this junction. Okay, let us say it is having a center of gravity here. Okay, let us say there is a force acting eccentric to the center of gravity. Okay, or CG, whatever you can say that. Okay, okay. Usually we will analyze a sum based upon its centroidal center of gravity. Then the force act analume, you will shift it to the center of gravity and we will analyze. Okay, that is the idea. Okay, but how to switch it over to the center of gravity? If in the sum பாத்தீங்க அப்படினா எப்படி switch பண்றது? Just like that, I cannot do that. Okay, even in mathematics you will do something for that. என்ன பண்ணுவீங்க? Mathematicsல பாத்தீங்க அப்படினா ஒரு equation இருக்கு. There is some complex equation. Okay, so there is some x, there is some y. Okay, இந்த x வந்து ரொம்ப காம்ப்ளிகேட்டடா இருக்கு அப்படினா என்ன பண்ணுவீங்க? What you will do?
Sir, add and subtract.
Okay, add and subtract one option, or you will just numerator add பண்ணி denominator divide பண்ணிடுவீங்க. This is one thing, and you will just add and subtract. Yes. Yes, these are some of the techniques you will do that. Okay, so in that process என்ன பண்ணிடுவீங்க, இதை simplify பண்ணிடுவீங்க. So அந்த மாதிரி we have to do something here. என்ன பண்ணலாம் அப்போ?
couple.
ஓகே, அது ப்ராடக்டா வரும், பட் இண்டிவிஜுவலா வந்து உங்களுக்கு டிஸ்டர்ப் பண்ணாது. ஸோ அந்த மாதிரி தான் இங்கேயும். ஓகே, ஸோ மேத்தமெட்டிக்ஸ்ல ஃபாலோ பண்ண மாதிரி தான் இங்கேயும் பண்ணணும். என்ன பண்ணலாம்?
So you have to apply equal force and opposite force to that.
Exactly. So you have to, what you have to do is, so here you can draw two forces, okay, opposite to each other. So in real sense, both will cancel out. So it is like as if it is nothing is there. Okay, wow. In real sense, பாத்தீங்க அப்படின்னா this is zero. ஏன்னா force இருக்கு, equal and opposite force இருக்கு, both will get cancelled out. Okay, but by making use of this, we are going to do something. Okay, what we will do is we will consider these two. Okay, I'll take a different pen. Please note it down. We will consider these two. Okay, by making use of these two, what we can do? We can என்ன பண்ணலாம்? Actually என்னது actually அது ரெண்டும்?
It's a couple.
It's a couple. Okay, so what we can do is we can consider these two as a couple acting in the clockwise direction. Okay, so now we can say that there is a force acting as usual, and also along with that there is a couple. Okay, so an eccentric force is something, it's a combination of two, a force and a couple. Now do you get it? Okay, so how to tackle eccentric force, how to solve the eccentric force is this by using the principle of superposition. Okay, so you have to consider equal and opposite forces, and you can take a couple out of it and you can add both. So basically there will be a direct stress. Okay, there will be a direct stress plus couple நிறைய type இருக்கு actually. There is a bending couple, there is torsional couple. So out of these two, what can this couple be? Is that torsional couple or bending couple?
Bending side.
Exactly. So உங்களுக்கு புரியலன்னா பாத்துக்கோங்க. So force இப்படி ஆக்ட் ஆயிட்டு இருக்கு, ஓகேவா? So அங்க ரெண்டு ஃபோர்ஸ் நான் இப்படி ஆப்போசிட்ல கொடுக்குறேன், ஓகேவா? So இந்த ரெண்டு கப்பல் நான் எடுத்தேன் அப்படின்னா it will try to bend the object. So இந்த மாதிரி தான் பெண்ட் ஆகும் object. Okay, so what acting here is bending couple. Torsion couple அப்படின்னா it is like twisting, rotate பண்ற மாதிரி. So couple வந்து இப்படி ஆக்ட் ஆகணும், z axisல ஆக்ட் ஆகணும், பட் அப்படி ஆக்ட் ஆகல. couple வந்து பாத்தீங்க அப்படின்னா force இங்க ஆக்ட் ஆகுது, இங்க ஒன்னு opposite force ஆக்ட் ஆகுது. So there is a couple acting perpendicular to the plane itself. Okay, so if the couple is acting perpendicular to the plane, then it will be the bending couple. Okay, that should be the understanding. So bending couple will be acting. Right? So this is what we have to do in this sum. Okay, now can you solve this? Now can you solve this? Okay, so sigma equal to, what shall be the total force actually? So it is combination of sigma direct plus sigma another bending. Is that right? Okay, so this is cost due to couple, this is cost due to direct stress. Okay, do you have any doubts here? If you have any doubts, you can stop me here. Any doubts?
No.
Are you all good? Srinivas?
Yes, sir.
Charan?
Thanks, sir.
Yes, sir.
Right, so all good, right? Okay, so now what we have to do is, All you need is just to apply the formula. What is the direct stress formula here?
P by S.
Exactly. So P by A. What about the bending stress formula?
So M by
Sorry?
M by I, sir.
Okay. It is actually M by Z. So Z is section modulus. But in general, we call it as MBY by I. Okay. So இதெல்லாம் வந்துட்டு very basic, very fundamental. You have no reason to be wrong in this. Okay. இந்த மாதிரி சிக்மா டைரக்ட் சிக்மா பெண்டிங்லாம் வந்துட்டு எப்ப கேட்டாலும் கரெக்டா சொல்லணும். டவுட்டே வரக்கூடாது. ஸோ இதெல்லாம் டவுட் வந்துச்சு அப்படின்னா we will be doubting you that whether you have studied mechanical or not. So these are that kind of basic things, basic fundamentals, because these things are studying from so long. 11th standard la படிச்சிட்டு இருக்கீங்க. So you have no reason to be wrong. Okay. So இதெல்லாம் எப்ப கேட்டாலும் கரெக்டா சொல்லணும். Okay. So இது தப்பாக சொல்லாதீங்க. Either I can call it as MBY by I, sorry, or I can say that MB by Z, because Z is nothing but I by Y. Okay, wow, this is what we call section modulus. This is another actual. I is what?
Area moment of inertia.
Exactly. So adu confuse avakudadu. Okay. If there is bending acting in this particular sum, a particular problem, if there is bending, then it will be area moment of inertia. Okay, wow. Mass moment of inertia irukkalama அப்படிங்கிற டவுட்லாம் வரவே கூடாது. Okay. If it deals with bending, it should be area of moment of inertia. Okay. And if it deals with RPM, if it deals with mass, then it can be mass moment of inertia. Okay. If it deals with area, then it should be area moment of inertia. Okay. So this is area moment of inertia to be precise. What is Y? What is Y?
Distance from the neutral fiber.
What is that?
Distance between neutral fiber and the top.
Yes. Distance between the neutral fiber and the
Area of acting point.
no.
Top fiber, sir.
Point.
Top fiber nu solradha outer fiber nu sollaam. Okay. So distance between the outer fiber and the neutral axis actually. Okay. My next question will be, what is neutral axis? Is the neutral axis and centroidal all same? Yeah, neutral axis nu solrom. So in this case, of course, the neutral axis is this, and also it is centroidal axis.
Bending is 0.
Yes. So here both are same, neutral axis and centroidal axis. Okay, it's because we have a square section. Okay, we have a section without any bend. Okay, so without any bending, central axis and neutral axis will coincide. Both will be same, but it will not be the same case for every cases. Okay, there can be difference. Okay, there can be different scenarios where centroidal axis and neutral axis will not coincide. Okay, so neutral axis and central axis are all not the same. Central axis is about the center of the area. ஒரு ஏரியா இருக்குன்னா அது சென்டர் தான் centroidal axis. அங்கதான் வந்து central axis வரும். Whereas neutral axis அப்படிங்கிறது பாத்தீங்க அப்படின்னா, if there is a bending load acting, so for suppose if there is a force acting here, for example I'm saying, if there is a force acting here, so it will try to bend this particular beam, right? Bend ஆகும்போது என்ன ஆகும் அப்படின்னா, இதோட cross sectionல பாத்தீங்க அப்படின்னா ஒரு சைடுல டென்ஷன் ஆக்ட் ஆகும், இன்னொரு சைடுல என்ன ஆக்ட் ஆகும், compression act ஆகும். Okay, so if there is a load acting here, it will try to bend the beam like this, இல்லையா? இந்த மாதிரி beam bend ஆகும். So இந்த மாதிரி bend ஆகும்போது டென்ஷன் எங்க இருக்கோ அங்க பாசிட்டிவ் சைடுல வந்து உங்களுக்கு ஃபோர்ஸ் ஆக்ட் ஆகும், கம்ப்ரெஷன் இருக்கிற இடத்துல நெகட்டிவ் சைடுல ஃபோர்ஸ் ஆக்ட் ஆகும். பட் அட் த சென்டர் there will not be any force. There the force will be 0 or neutral. That's why it is called neutral axis. Okay, neither positive nor negative. That's neutral axis in solrong. Is that clear? Is that clear?
Yes, sir.
Okay, but in இது வந்து beam straight ஆ இருக்க வரைக்கும் தான். Suppose if there is a bended beam, even before applying the load itself, load apply பண்றதுக்கு முன்னாடியே beam bend ஆ இருந்துச்சு அப்படின்னா any application உங்களுக்கு மைண்ட்ல வருதா ஏதாவது? load apply பண்றதுக்கு முன்னாடியே bend ஆ இருக்க beam ஏதாவது ஒன்று சொல்லுங்க பாருங்க, எக்ஸாம்பிள் சொல்லுங்க. Any such examples?
So bridge
load apply பண்றதுக்கு முன்னாடியே bridge bend ஆயிருக்குமா?
இல்ல சார்.
Sometimes corruption பண்ணியிருந்தா அப்படி இருக்கும், but we should not take into account of those. காசு வாங்கிட்டு கட்டின பிரிட்ஜா இருந்தா அப்படி இருக்கும். But any mechanical examples where we have application? Okay, springs is a different kind of application, but you are right. It's one of the application, but more precise application can be crane hooks that we were discussing just before 5 minutes. Okay, crane hooks பாத்தீங்க அப்படின்னா normally எப்படி இருக்கும், இந்த மாதிரி bend ஆகி தான் இருக்கும். Okay, so here the centroidal axis and neutral axis will not go inside. Okay, so these are one such application. So we will be discussing this topic in very detail in next class. So இப்போ நம்ம discuss பண்ண வேணாம். So let us try to finish off this particular sum. Okay, so இது நமக்கு பிரச்சனையே கிடையாது. 12.5 நம்ம previously solve பண்ண மாதிரி ஆன்சர் வரும். But what about this one, mby by I? What is bending moment here? Bending moment என்னவா இருக்கும்? Any idea?
5 into 10.
Okay, it is actually 5000 இல்லையா? 5 kilonewton இல்லையா? So 5000 into
10, sir.
10. இந்த 10ங்கிறது என்னது?
Millimeter.
Sorry?
Millimeter, sir.
இல்ல 10ங்கிறது என்னது ஆக்சுவலா? Where you have taken this 10?
Distance between applied force and the neutral. Center.
Yes. Neutral axis சொன்னது கரெக்ட் தான். Distance between the centroidal axis, I mean moment பொறுத்த வரைக்கும் centroidal axis தான் கன்சிடர் பண்ணுவோம். You are right. Centroidal axis and the line of action. Okay, so இதுவும் the distance between these two, இதான் eccentricity ன்னு சொல்லுவோம். Okay, to be precise, it is what we call eccentricity. Okay, so that 10 is for eccentricity. What about y then? What is y then? Y is normally the depth of the cross section divided by 2. Okay, so in this case the depth shall be 20. Okay, so it is 20 divided by 2. Okay, y d by 2 ன்னு சொல்லுவாங்க, or you can say that distance between the outer fiber and neutral axis. So outer fiber neutral axis distance எடுத்தீங்க அப்படின்னா இந்த பாயிண்ட்ல இருந்து இந்த பாயிண்ட் எடுக்கணும், which is nothing but 20 divided by 2, 10 அதுதான் வரும். Okay, so it is 20 divided by 2. What about I then? So it is, as you guys said, it is a area moment of inertia. So what is the area moment of inertia for square cross section?
A power 4 by 12.
Exactly. A power 4 divided by
12.
Sir.
Exactly. So it is a power 4 divided by
12.
12. Exactly. So normally rectangle என்ன போடுவோம்? BDQ by 12 போடுவோம். So in this case B and D are same in the form of A. So it is a power 4 divided by 12. Okay, so easy now வச்சுக்கோங்க. Come on, solve for this sum. அவ்வளவுதான். We have taken the formula. Now we can directly solve. Yeah. So in this case it is 20 power 4 divided by 12. So what is the final value?
50, sir.
50.
50.
Newton per meter.
12.5 இது 50 இது மட்டுமே 50 வருதா?
37.5, sir.
Okay, 37.5. Okay, so this thing you have to understand. Okay, so a force just central எப்படி ஆக்ட் ஆகாம இப்படி ஆக்ட் ஆகுது. அதனால how many times there is more stress acting in the middle அப்படிங்கிறது பாருங்க. Okay, சும்மா கொஞ்சம் தள்ளி ஆக்ட் ஆச்சுனாவே இவ்வளவு வந்து ஸ்ட்ரெஸ் ப்ரொடியூஸ் ஆகுது. That's why eccentric loading is very dangerous. Okay, so you have to give additional support for eccentric loadings. Okay, so central act ஆச்சுனா 12.5 தான். Just 10 millimeter தள்ளி ஆக்ட் ஆனதுக்கு 37.5 Newton per mm square more stress is acting in this particular element. Okay, so that's why eccentric loading is very critical. Okay, so you should be very cautious about this.